Hey everybody, my name's Justin. Today I'm going to be explaining the concept of conduction. So first of all, what is conduction? Well, conduction, simply put, is just the transfer of heat directly through a solid object. Okay, so an example of that would be when you put a pan on the stove and you put something on the pan to cook it, that heat is directly transferring from the pan directly into the food. That's two solid objects touching, and that heat is transferring directly from the pan into the food. Another example would be if I pour some hot water into my mug, right? I'm gonna be able to feel the heat from that hot water through the mug as I hold the mug. That's why, mugs put these handles on there so you don't actually have to touch the hot side of the mug. You can also think of it if you were to leave a metal spoon in a boiling pot of water on the stove, and you later go to take that spoon out, the end of it's going to be really hot. That's why you want to use a wooden spoon or a plastic spoon when you're cooking. All right, so here I have two blocks. And if you look at these blocks, they look pretty much the same. But if I tap it on the table, you can hear that they sound much different. They're made out of two entirely different materials. Based on the sound of this one, you can kind of tell that that's probably made of metal. And from the sound of this one, it's probably made of wood or plastic or something like that. As I touch these two blocks, I notice that this one, the one that sounds like metal, feels really cold to my hand. And this one just feels room temperature. Now I'm gonna do an experiment where I take both of these blocks and I'm just gonna put an ice cube on each one of them, and let's see what happens. All right, so watch what happens as I put an ice cube on the one on the left. Pretty much nothing happens, right? It's just sitting there. When I add an ice cube to the block on the right, notice what happens. It starts to melt right away. Clearly we can see the one on the right melting much faster than the one on the left. How is it possible that this one that felt colder when I touched it earlier is actually melting the ice faster than the one that felt warm or room temperature? So the way it works is metals are very good conductors of heat. Heat easily travels through metals. So what happened in this case was, even though the room that I'm in does not feel super hot, there's still heat here. There's heat coming off of my body, there's heat in the room. And so that heat is being pulled through that metal block, and it's transferring it or conducting it directly into that ice cube, and it melted very fast. On the plastic one, plastic is a really bad conductor of heat. Heat does not easily travel through plastic. So what that means is the heat that's coming off of my body and in the room is not able to transfer through this block, and so it's not reaching to the ice cube. So what we call things that are not good conductors of heat is insulators. Insulators are very bad at conducting heat, and that includes things such as plastic, styrofoam, rubber, air is a really bad conductor. Basically anything that's a non-metal is what we would call an insulator. Most of our cooking tools that we use are made out of some type of plastic or rubber material so that the heat from our cooking doesn't go into our hand and burn us. Wow, check that out. The one that's on the metal block, the one on the right side, is almost completely melted. There's just a little left there. And the one on the plastic has barely melted at all. So just to recap the main points from this video, conduction is the direct transfer of heat through direct contact. Conductors are materials that are very good at conducting heat, and those would be metals, all kinds of metals. Insulators are materials that are not good at conducting heat or very good at blocking heat. Thanks so much for watching the video. I hope it was helpful. I hope you enjoyed it. If you did enjoy it, please leave a comment down below and be sure and like and subscribe to the channel. Thanks so much, everybody.